Hello, mathematicians. Today we're learning about absolute value inequalities. So, what are the solutions of an absolute value inequality? Here we have the absolute value of x is less than 4. And normally we're used to looking at x is less than 4. So what I'm going to do is I'm actually going to plot x is less than 4, and then we're going to see how it's a little bit different. So if we were plotting x is less than 4, we would draw an open circle on 4 because 4 is not included, and x is less than 4, so we would actually shade to the left. And that is true for x is less than 4. So let's see how it compares to the absolute value of x is less than 4. So let's take negative 5 for example. The absolute value of negative 5 is 5, and 5 is not less than 4, so that makes that number at least not true for our inequality. So negative 5 is not a part of our inequality. So let's try negative 4. The absolute value of negative 4 is 4, and 4 is not less than 4, so 4 cannot be included. However, everything else is. So I'm going to move my line over, and I'm going to put an open circle on 4 because negative 4, because negative 4 is not included. So everything in between here is actually true. So negative 3, the absolute value of negative 3 is 3, and that is less than 4. The absolute value of negative 2 is 2, and that's less than 4. The absolute value of negative 1 is 1, and that's less than 4. And even all our numbers in between, such as 3 and 5/10, 3 and 75/100, negative 3 and 5/10, negative 3 and 75/100. So everything that is shaded is true for this inequality. So we could actually write out our inequality as negative 4 is less than x less than 4. Because negative 4 is our minimum here. X is everything in between negative 4 and 4, and 4 is our maximum, okay? And another way we could think about it actually is we know that x could be positive or negative because then the absolute value makes it positive. So we could actually write x is less than 4 and negative x is less than 4. And let's see what we get by doing this. So this is very, very similar to when we were working with absolute value equations. So given this, I don't have to do anything here because x is less than 4. That's perfectly fine the way it is. But here I have negative x, so I'm going to divide both sides by negative 1. Technically, there's a coefficient of negative 1 here, and that's why we're dividing by negative 1. So that when we divide those, it's 1 and that cancels out. And then here we're left with x. And remember that when we multiply or divide by a negative, the sign flips. X is greater than negative 4. So let's look at these two inequalities. We have x is less than 4, which is included here. So I'll do this. So x is less than 4 is included here. And x is greater than negative 4 here. This inequality is actually included here, but it's flipped a little bit where x is greater than negative 4. So these two are true. And if we plot them, we could see it's x is less than 4 and x is greater than negative 4, and that is why we could just write one inequality to include all of that. Here we have the absolute value is greater than 4. And I'm going to start the same way I did before, where I'm going to do x is greater than 4. And I'm going to put an open circle on 4. because 4 is not included, but I'm going to shade to the right this time because it's greater than. Okay, so if I do that, that's true for x is greater than 4, but x here, let's see other numbers here that might be true. So for example, I'm going to start with -5 again. The absolute value of -5 is 5, and that's greater than 4, but that's not included here. So what we have to do, as we did before, is we're going to write out x is greater than 4 and negative x is greater than 4. And here I could leave this because this is just fine, but here I do have to divide by -1 to isolate the x. So that cancels out. X is less than, because we're dividing by a negative, our sign flips. X is less than -4. And now I did have this graphed, but I also have to graph this on our number line. So x is less than -4. -4 is not included. And since it's less than, I'm going to shade to the left. So here I have shading on both sides. So we have x is greater than 4 or x is less than -4. All right, so here I have the absolute value of x divided by 4 is less than or equal to 3. And we're going to do the same thing. We're going to do x over 4, well, x divided by 4 is less than or equal to 3. And then we're going to have our negative version, which is negative x divided by 4 is less than or equal to 3. And what we could do is here, if we want to isolate our x, we can multiply by 4. That cancels out. Multiply by 4. So in this case, we have x is less than or equal to 12. And here, we could either multiply by negative or we could divide both sides by negative. So I'm just going to write negative x over 4 is less than or equal to 3. If I want to isolate the x, I could actually multiply by -4. Multiply the other side by -4. Because I'm multiplying by a negative, flip the sign. X is now greater than or equal to -12. So let's plot this first on the number lines to see what it looks like. So I'm going to draw -12 on one end here. I'm going to draw a 0 somewhere in the middle. And then I'm going to draw 12 over here. And we know that x is less than or equal to 12. So I'm going to draw my open circle. Oh, sorry, closed circle because 12 is included. And since it's less than, I'm going to shade to the left. But I'm not going to go past this because x is also greater than or equal to -12. So this one is included. So one would shade to the right, one would shade to the left, and they would overlap. So because our inequality includes both, it's x is less than or equal to 12 and x is greater than or equal to -12, or a better way to do it is we can write one inequality to include everything. So -12 is the minimum, and that's less than or equal to x, which is less than or equal to 12. So -12 is the minimum. It's included because of the equal sign. X is everything in between, and 12 is the maximum. Here we have the absolute value of negative 7x is less than or equal to 70. So we could write that out as negative 7x is less than or equal to 70, and negative 7x is less than or equal to 70. And here, to isolate our x, remember that we have to divide both sides by negative 7. Negative 7 divided by negative 7 is 1. X is now greater than or equal to, because we divided by a negative, greater than or equal to negative 10, because 70 divided by negative 7 is negative 10. Here, negative times a negative, we have 7x is less than or equal to 70. To isolate the x, we divide both sides by 7. So x is now less than or equal to 10. So what I'm going to do on our number line is I'm actually going to draw out negative 10, 0, and positive 10. And we're going to start off with our first inequality. X is greater than or equal to negative 10. So remember that it's included. And because it's greater than, we're actually going to shade to the right. So if we shade, we're going to shade to the right. And then we notice here that x is less than or equal to 10, so I can't go past that. Again, it's included, so it's going to be a shaded circle. And another way that I could write out my inequality to include both of these is negative 10 is less than or equal to x less than or equal to 10. So here we have another inequality. So what we're going to do is I'm going to read it out first. So 9 times the absolute value of x minus 8 minus 6 is less than 30. So we're going to start off by trying to isolate our absolute value. And in order to do that, first we're going to add 6 on both sides. So I'm left with 9 times the absolute value of x minus 8. Remember, just because you don't see the multiplication sign does not mean that it's not multiplication. This cancels out, is less than 36. The next thing I'm going to do is I'm going to try to cancel out that 9 by dividing by 9, because multiplication and division are inverse operations. That cancels out, and I'm left with the absolute value of x minus 8 is less than 4. So I'm going to do the same thing that I've been doing before, is I'm going to write it as x minus 8 is less than 4, and negative times x minus 8 is less than 4. So we're going to try to isolate x in our inequality. So we're going to do that by adding 8 on both sides. And this one was nice and easy because x is less than 12. And here we're going to distribute the negative, or you could divide by the negative first. It's the same thing. So we're going to have negative x plus 8 is less than 4. Next, we're going to subtract by 8 on both sides. And now we have negative x is less than negative 4. And now we're going to divide both sides by negative 1. So x is now greater than 4. So I'm going to plot this on our number line. I'm going to start off with maybe putting 0 somewhere here, 4, 8, and 12. And I'm going to look at my first inequality. X is less than 12. So what that means is that 12 is not included, so that's an open circle. So I'm going to draw that. And since it's less than, I'm going to shade to the right. To the left. And I'm going to stop here because x is also greater than 4. So this has an open circle. So x is less than 12 and x is greater than 4. And that's represented by our inequality here. So if we want to combine that, we're going to write 4 is less than x, which is less than 12, okay? Because x has to be less than 12 and greater than 4 for this to be true. So we have the absolute value of 10 plus 4x divided by 2 is less than 7. So what we could do first is we could actually multiply by 2 on both sides so that we could cancel this out. Because multiplication and division are inverse operations, we can multiply here by 2. And now we're left with the absolute value of 10 plus 4x is less than 14. So with that, we have 10 plus 4x is less than 14, and the negative 10 plus, so negative times 10 plus 4x is less than 14. So what we're going to do first is we're going to isolate our variables. So we're going to subtract by 10 on both sides. We're left with 4x is less than 4. And in order to isolate x, we're going to divide both sides by 4. So x is less than 1. Here, we could either distribute the negative or divide by negative 1. So if we do distribute the negative, we have negative 10 minus 4x is less than 14. So we could add 10 on both sides. And we have negative 4x is less than 24. And here we could divide both sides by negative 4. So x is greater than 24 divided by negative 4 is negative 6. And don't forget to change the inequality because we are dividing by a negative. So here on our number line, I'm going to write out negative 6, 0, and 1 would be a lot closer to 0 than negative 6. So x is less than 1, but x is greater than negative 6. So we're going to draw an open circle in 1, and we're going to shade to the left, but we're going to stop just before negative 6 because x is greater than negative 6, but negative 6 is not included. So given this, we could write an inequality that includes everything. So negative 6 is less than x, which is less than 1. All right, and last problem. Here we have the absolute value of 7 minus 2x plus 4 is less than 11. And what I'm going to do first is I'm going to subtract 4 to isolate our absolute value. And I'm going to do that on both sides. So now we're left with the absolute value of 7 minus 2x is less than negative 15. So given that, we're going to do 7 minus 2x is less than negative 15, and negative times 7 minus 2x is less than negative 15. And we're going to isolate our x. So we're going to subtract 7 on both sides. And we're going to divide by negative 2. So x is now greater than 11. We're going to distribute the negative here. So negative 7 plus 2x is less than negative 15. We're going to add 7 on both sides. Two x is less than negative 15 plus 7 is negative 8. Divide both sides by 2. And x is less than negative 4. So let's see what that looks like on our number line. So I'm going to put negative 4 here, 0 here, and then 11 somewhere here. So for the first one, x is greater than 11. And we're going to shade to the right. And x is less than negative 4. So we're going to shade to the left. So for this inequality, we solved our inequality, we plotted it, and everything looks good, right? But let's actually try one of these solutions. So anything that's shaded should be a solution. So if I picked 12, because it's shaded, it should make this inequality true. So let's see what happens when I substitute in our inequality. So 7 minus 2 times 12, absolute value. And I'll use this one because it's a little bit easier and it's the same thing, is less than negative 15. So here I have the absolute value of 7 minus 24 is less than negative 15. And 7 minus 24 is actually negative 17. And without the absolute value, this would be perfectly fine because negative 17 is less than negative 15. However, we have an absolute value here, and the absolute value of negative 17 is actually 17, which is not less than negative 15. And the reason for that is because our absolute value is less than a negative, and our absolute value will only ever be positive. So there's no possible positive number that's ever going to be less than negative 15. So be very careful with that. In this case, we were able to solve our inequality, but these solutions are not true, and therefore in this case, it's no solution. Because if we have an absolute value that's less than a negative, it is not possible. So be mindful of that.